everyone. Welcome to the StarAgile YouTube channel. I'm Sonal Mittal and I work with StarAgile and conduct various trainings on DevOps. We provide training also on DevOps tools like Ansible, Docker, Kubernetes, Jenkins, and monitoring tools. Today, we will be discussing about the DevOps interview questions and answers for freshers as well as for working professionals. But before we move ahead, please click on the subscribe button and join us on this exciting journey to master DevOps. What better than learning DevOps with the help of question and answers? Here I present to you the topmost interview questions that you will come across during interviews. The very first and the popular interview question that we have are the various tools that you have worked about in DevOps. You know that DevOps is not a programming language. It is not a theory. It is not about a team. DevOps is a methodology. DevOps is a process. DevOps is all about automating your SDLC process. So when I talk about the SDLC process, there are various phases in it. And each phase can be automated with the help of a DevOps tool. Let us have a quick look at it. So let us quickly draw an SDLC phases. So the very first phase that we look at is planning. But as a DevOps engineer, we may not concentrate much on the planning phase. The first phase that we want to work with is the coding phase. Once the requirements given by the client are frozen, these requirements are shared with the IT team members who will then convert the semi-formal language written requirements into a program or a code into a working application. The output is a source code that you see on my screen. And to manage and maintain this source code, we make use of tools like Git, GitHub, Bitbucket, GitLab, TFS, code commit, and so on. Now, one of the major principles of DevOps is communication and collaboration. So multiple team members will write the source code and collaborate together on these version control platforms, which are GitHub, Bitbucket, and so on. Some of them are community version, as well as there is enterprise version of the tools also available. The next phase that comes in the SDLC is your build phase. And that is automated via the tools, which is Jenkins. You have Travis, you have Bamboo, you have GitLab, CI/CD pipelines, Azure pipelines, AWS pipelines, and so on. Right? The build is a process where we compile the code, we test the code, we package the code into an artifact. Whenever we have to deploy the code, this package is deployed onto the servers. Build process can be automated with help of the integration tools that you see on my screen. However, build process is automated via the build tools like Maven and Gradle, MS Build, PyBuilder, and so on. Those tools are used manually by the developers. As a DevOps engineer, we are supposed to automate these tools. We are supposed to automate the process of build with help of Jenkins, where we create the CI/CD pipelines. After the build process is completed, we have the process of integration testing or end-to-end testing. So for which you can take, we can also call it as a functional testing, for which we can use tools like Selenium, you have Cucumber, you have tools like, as part of Selenium, there are major other testing tools that can be included. For now, we'll target Selenium. You have QTP also, which can be used as a functional testing tool. After this, we will go ahead and we'll deploy the code. In order to deploy the code, you can deploy the code manually, but we are talking about DevOps. So we use deployment tools like Docker, Kubernetes, which supports continuous deployment, and Ansible, which also supports deployment on virtual servers. So I'll list down over here. So if you want to deploy on virtual servers, you make use of Ansible. If you want to deploy on containers, then you make use of Docker. If you want to go with continuous deployment, which we will talk in the upcoming questions, what is continuous deployment? We are going to discuss that. You make use of the tool Kubernetes. In order to deploy our applications on a server, the server should be provisioned in a designed network, in the desired setup, right? Only then the server will be up and running. Now, provisioning of the infrastructure plays a very important role when we are deploying our applications. So that comes as part of the next phase. Now, I always tell the operations phase can be interchanged with the deployment. If your servers are not set up, your environment is not ready, then your operation stage comes first, where you provision the infrastructure via the tools like Terraform or CloudFormation or Ansible also can be used for configuration management and infrastructure setup, right? And then later you can deploy your code. After the operations is done, after the deployment of the code is done, the final step is to maintain the code, to manage and ensure that your code is reliable and your application is always available to the end users. So hence we add the step called as monitoring. In monitoring, you can make use of several tools, starting with Nagios, ELK Stack, Prometheus, Grafana, Datadog, and many more, right? So here is your automated SDLC, where you first collaborate the code over a version control tool like GitHub. You build the code with help of Jenkins and Maven, or if it is a Python code, we will build with PyBuilder. If it is a .NET code, we will build with MS Build. Then we perform the functional testing where Jenkins will pick up the automation test cases and test it. Like Selenium can be used here, Qt can be used here. Then we deploy the code. Deployment is a process of pushing your build on the desired servers. If you have to set up your servers, you make use of the tools like Terraform and CloudFormation, and finally monitor your applications. So this is how you can explain the various tools that you have worked on in your DevOps. So this covers my first question, and here is further explanation to what is CI/CD. So CI/CD stands for continuous integration and continuous deployment. Let me explain you continuous integration first with help of a diagram and then continuous deployment. Let's go ahead and look at it. So we'll continue with the same SDLC process. Let us consider that a developer pushes the code into, so I have a developer who writes the code for a given requirement and he will be pushing the code into GitHub. So we have the source code, let us say Java based code or Python code or your HTML code. Any code is available on your GitHub repository where multiple team members are collaborating the code. Great. Once the code is available, we need to compile the code. We need to test the code. We need to package the code. This process is called as the build process. The process of packaging the source code that involves compiling, testing the code, unit testing the code, and packaging. It's called as the build process. Now, traditional models included the build process from the very beginning, but it was performed manually with help of tools like Maven and Gradle. You will have .NET for C# or you have MS Build for them. And then you make use of PyBuilder if you have to build Python code. After this, we will build the code manually. But with DevOps, we want to automate this process of building the code. To automate the process, we make use of a tool like Jenkins, or you can use CI/CD tools on Azure or AWS, or a GitLab CI/CD runner can also be used. Latest tools that we use is a GitHub Actions also can be used for this process, where tools, let us consider our tool as Jenkins. So Jenkins is also called as an orchestrator, a continuous integration server, an automation server, or an orchestrator, which is responsible to pick up the code from GitHub and ask the build tool Maven to go ahead and build it. So here Jenkins acts like a collector. So as the developer pushes the code, so we're talking about first integration. An integration is a process where an automation tool like Jenkins integrates with GitHub to fetch the code. And Jenkins as a tool integrates with build tool to build the code, package the code. right? So there are two integrating activities that are happening, fetching the code and packaging the code. Okay. Now we want to do it continuously. So Jenkins supports automation triggers which when applied on Jenkins can sense the change that has happened on that has happened on GitHub. So let's say a developer pushes the code at 9 a.m. That is, he commits the code in GitHub. As soon as the code is available on GitHub, Jenkins will sense the change. It is also called in real time as a event-based pipeline. Jenkins will sense the change, pull the pull the required code, and package it by other tool like Maven or Ant or Gradle. Right? So here in Jenkins, implementation of triggers supports continuous integration. Continuous integration is a process of picking up the code from GitHub and compiling it and testing and packaging the latest code shared by the developer. Now, in case there is a negative impact also, in case there is an error while compiling the code or packaging the code, Jenkins as a tool notifies the developers. Jenkins as a tool notifies the developer to fix the code. Developers will fix the code, push the new code. Jenkins will sense the change and again ask the build tool to compile package. Once the package is available, Jenkins will integrate with artifactories to push the artifact on the registry, like artifactories like JFrog artifactories, Nexus artifactories, or registries over the cloud can be used to maintain the artifacts. So that is your continuous integration process. Now, once the artifact is available, let me also list down here. Once the artifact is available, let's say in the artifact it is available, the next step is to deploy the code. Now to deploy the code, we need, let's say 3 environments are available. We generally have the test environment, staging environment, and then finally we have the production environment. So there are two parts when we talk about CD. CD can be continuous delivery, can be continuous deployment. So when I talk about continuous delivery, so here we're talking about the QA environment, test environment, pre-prod environment. You can call it as a staging environment. You can call it as a user acceptance testing environment and a production. Okay. Now, when we talk about QA over here, or we talk about continuous delivery first, continuous delivery is a process where you use an automation tool that will take your build and deploy it on the test environment. So the output of the build phase was, let us say, an application.war file. Okay. This war file is automatically picked up by Jenkins and pushed, that is copied or deployed on a QA server, right? And then here we perform testing that can be performed via automation tools, Jenkins, which will pick up the Selenium code from GitHub, execute the test cases. In case of any issues, the application is not working, we report it to developers via the email or via Slack notification. Then the developers fixes the code, a new build is generated and deployed in the test environment. If testing goes fine, using an automation tool to deploy the code onto the pre-prod environment. So the successful build, the tested build, is then pushed into the pre-prod environment. Okay, here. Once it is pushed into the pre-prod environment, we perform performance testing, load testing is performed here using tools like JMeter, Load Runner. And finally, once the acceptance testing is completed, we will stop deploying of the application via a tool into the production. So continuous delivery is a process where an automation tool will deploy in QA and pre-prod environment. However, deployment to the production environment is performed manually by getting approvals from the stakeholders, and on a given date and a time, we will deploy the code into the production manually. We will run the commands to push the code. However, when we talk about continuous delivery, which DevOps supports, we use an automation tool to immediately deploy the application over the production server also. So all the e-commerce applications that you see, they all support continuous deployment process, where as the code is written, Code is built, immediately tested via the automation tools, and then pushed to the production environment. That is why nowadays you see what you request is immediately available in few hours or sometimes even in few minutes because of continuous deployment. So this covers my second question, which is CI/CD, continuous integration, where developers regularly merge the code, and the build automation tool, continuous integration tool like Jenkins, frequently pick up the code and builds a continuous delivery process where you are manually deploying into the production environment, a deployment process where your application goes live within few minutes or within few hours instead of days. Continuous deployment. Great. Now, here are some of the benefits of DevOps. This also summarizes my first two questions. So, when you're working with DevOps, you are making use of various tools. So, since we are working with various tools like GitHub, Jenkins, build tools, testing tools, deployment tools, our implementation of SDLC is much faster. And since a tool is used, there will be less human errors. Previously, with deployments, there were many, if any command is missed, if any file is missed, our deployments would fail. But nowadays, because of automated deployments, especially with containerized applications, the chances of failures are less. That supports zero downtime to the end users. Because of continuous integration, the quality of the code is very good that is going to the end users, right? So these are some of the main benefits. Also, in traditional models, we had less collaborations and communication between the development and the operations team. So DevOps supports communication. There are development team and operations team work together, right, in order to deploy the code immediately. And there are less failures because of tools used and faster deployment. Scalability, because we are using automation tools like Terraform, CloudFormation, it allows us to scale up the infrastructure at a very faster rate when compared to the traditional models. So what are the best practices in continuous integration? So as we discussed, so I'll quickly show you via the tool itself. We discussed frequent build, frequent commits. So on the GitHub, let me show you the tool. So here I have opened a GitHub repository. So as I told you, there is an automation tool, GitHub Actions also. So here I have written a code. I'll show you a code in a minute. So this repository, our developers have provided some source code. So as a developer will commit into this repository, immediately the continuous integration tool will pick up the code. So I've written some code here. I'll quickly show you, which is using the tool called as GitHub Actions. Do you see Actions on the GitHub repository? It is also the latest continuous integration tool. So the GitHub Actions allows us to implement CI/CD process where you tell on which branch do you want to perform the continuous integration. Then here you will make use of the tools. Let me scroll down. Okay, so here it is making use of the tools like Maven to build the code and Docker to deploy. Now you may also try to see it in Jenkins. I have some pipelines over here, continuous integration pipeline. Let me quickly log in. So this is another tool which is Jenkins, which also supports continuous integration. Inside this tool, so you can see a pipeline here, a beautiful pipeline is visible where we are having the first step of cloning the repository. So the question says is, what are the best practices of continuous integration? The best practices are, first and foremost, you are writing the code in order to perform continuous integration. So when we are writing the code, the process is much faster. Okay. So the code involves fetching the code, compiling the code, testing the code, and packaging. Writing the code is very easy in the continuous integration tool like Jenkins. Second step is you can integrate Jenkins with help with email notification. Like if you see in this particular tool, let's say I'm generating reports and I want to send that report to my team members. So one other advantage of using integration tool is I can integrate, generate the tool, give it a moment for it to start. and I can send notifications via email. So let's give it a moment to start. In the post build steps, we can add a step. So this report needs to be sent. So we can add email notification. So we can add recipients to whom we can send emails, whether our job has passed or failed, and we can also attach the report with it. That is second benefit of using a continuous integration tool. The third benefit is you can, of course, do continuous testing also, deployment also we can do with this tool. In addition to this, you can also integrate with the version control tool, right? And I also like some of the features of Jenkins or any integration tool is it supports multiple people to work at the same time, right? It also integrates with thousands other tools, giving you automation at a very high level. It also allows you to ensure high availability of your servers. You can work with the setup of clouds, right? Where you it can help you to scale up your Jenkins server or help you to scale up the servers where you want to deploy your code. You can also integrate Jenkins with other virtual servers to distribute the workload. So these are some of the important features of Jenkins. So when you inform or when you attend an interview on continuous integration question being asked to you, then some of the advantages of continuous integration is, of course, a faster build, higher quality, continuous testing, reports will get generated, plus you can send notifications to different team members. Now, here is a theoretical question where you can explain with help of the example of what is the difference between DevOps and Agile. So Agile, when extended to the operations team, forms DevOps. So if you see in this diagram over here, Agile is a process where you break down your requirements into small user stories. These user stories are then developed, tested, and reviewed. A demonstration is given to the client. Upon his feedback, we make changes and complete the sprint. So Agile is a process of incremental development. It's a development model. Unfortunately, you don't deploy immediately. Just a second. You don't deploy immediately. You may deploy fortnightly or monthly or 3 months deployment you may have. However, in Agile, there is a communication between the developers and testers. They are working closely to develop the code at a faster rate. However, deployment is done on a given fixed date and time. But when we talk about DevOps, it overcomes the challenges of Agile and it extends the communication with the operations team. The development, testing, and operations team work together to automate the SDLC to deliver an application at a faster rate. DevOps is coined from two terms, development plus operations, right? And it's all about automation. It's all about automating your workflows for monitoring and making your application available to the end users. Okay. So Agile focuses on development, DevOps focuses on faster deployment. It's a deployment model. Now, here are a question which is inclined towards Jenkins. So what are the various security options that we have in Jenkins? So Jenkins is a secure tool. Of course, you need to add some more actions inside Jenkins to make it more secure, like SSL certificate can be added, ensuring it is highly available. Then in addition to this, Jenkins comes with its own inbuilt security feature. Let me show you over there. If you go to the Jenkins dashboard and go to manage Jenkins, over there you have security part. In the security, you can create multiple users in Jenkins and we can give credentials to them. So there will be a secure access to each team member. In addition to this, the users also have role-based access. Like you can provide them roles or metrics-based access, we call them in Jenkins. In this case, we can give read-only access, read and write access to the jobs. They can create jobs, delete jobs, or only view the jobs. So that security part is taken care in this section, making Jenkins secure. Here, there are three different types of authorizations. So first and foremost, security realm is a component of Jenkins where we will see Jenkins is storing its data inside its own database. Okay, you can also connect Jenkins server to LDAP, which is commonly used in real time for maintaining the user database. But by default, Jenkins uses its own database in the Jenkins default directory var lib Jenkins. Okay, when you look at the authorization part, we have 5 types of security settings in Jenkins. Now, if you set this, that means you don't need to log in. Anybody who has the IP address and port number of Jenkins server can do anything on Jenkins, which is risky. We don't select this. Then legacy mode is also not selected. It is just an access to the legacy project. Now, these 3 are important security settings that you can do. The default setting that we have is a logged in users can do anything. So this is the default setting. As you log in as an admin user or as a Tom user or Alice user, whatever is your user ID and password, you can log in and perform the activities. But in general, I would not give entire access to every user. Only admin will have the complete access. So we will go with metrics-based security. So when I talk about metrics-based security, then I can add a user, like let's say I add admin user. To admin user, I can give complete admin access that it can do anything. Or let's say to this user, I give, he can create jobs, he can read the jobs, he can move the jobs, then he can create an agent, he can delete. Agent is nothing but a distributed environment of Jenkins, a server. Then you can create credentials, or sometimes to a user, I may give only read access. He can only see Jenkins server, he cannot make any changes to it. So this is called as metrics-based security. Security based on the role. Then we have project-based security. So project-based security, that means on that particular job, the user has an access. So you can give an overall access as, let's say, admin user. Overall access, let me actually not give it to admin because admin should have complete access. Okay, so one user should have complete access. I'll create one more user. Let me see if I have the user. So you can create a user here. Let's say I'm creating a user Alice. I'm providing credentials to the user Alice. Now I'll give permissions to this user. So we will look at manage Jenkins, security, project-based security. When I go to project-based security, the admin user is having all access, which you should give. Otherwise, you will have to reset the settings of Jenkins. Then we will go with the Alice user that I have just created. To Alice, I'm giving read access. That means on my machine or on this Jenkins server, when Alice connects, she will be able to only see the jobs. She cannot edit the job. She cannot delete the job. She cannot execute the jobs. However, one job I'll give her full access. So that is project. In Jenkins, project means job. Metrics means read access, write access. What is the access we are giving? So here I will give dashboard. I'll take a job. Let's say I take a continuous integration pipeline and I go to configure and you will see an option of project-based security. Enable project-based security, first option. Here we can add Alice user and I'll give her full access. She can add, manage credentials on Jenkins. She can create jobs on Jenkins. And only this particular job. She can only work with this particular job. That's all. So I'm giving complete access to this job. And I save it. Okay. Now, if I log out, I'm currently logged in as administrator. I will log out and log in as Alice. Now, can you see she is only able to see only the job to which I have given her access. Rest all, she doesn't have access to manage Jenkins. She cannot create a job, but she can work with this job. She can build the job. She can configure the job. She can delete this pipeline, everything. Okay, so this way we can give restricted access to the users on Jenkins, isn't it? So this and admin user, however, has complete access. This is the answer to your next question, which is what are the different types of security settings that we have in Jenkins? That is role-based access, authentication, authorization, secrets that you can maintain, and security plugins. Now, what are the different DevOps life cycle? I think we have just discussed some time back the various stages of DevOps that can be automated in the SDLC. So first is the planning phase. In the planning phase, the developer, the client team, and the business analyst team will collect and freeze the requirements. Once the requirements have been frozen, once the requirements have been frozen, these requirements can be broken down into small user stories, and then for which these user stories are shared with the developers. Developers will start writing the code using high level programming languages like Python, Ruby, C Sharp, and so on, Java, JavaScript, and .NET. After the code has been written, the code has to be tested to verify and validate that the code is working. So we test the code and package. Now, package is a process. Package is a process where you will convert the code into a machine understandable code. Like your servers cannot understand Java, they understand zeros and ones. So build is a process where you compile the code, convert it into a machine understandable code, and package into an artifact that can be deployed. Then we write automation test cases using Selenium or QTP. Then we have the process of releasing the code to the deploy. So the build phase, once completed, is also called as make a release phase, where your code is ready to be deployed. Then we make use of the deployment tools like Ansible or Puppet or Chef or Docker. GitOps is used, CI/CD pipelines are used to deploy the code to the production. Finally, you also ensure that your servers are up and running and your servers are having the desired softwares and packages that are needed for your application to run. So operation stage involves infrastructure setup and maintaining the servers by doing the configuration changes. Then finally, we monitor the code, monitor the applications, get the feedback and fix it. At every stage, you can add a security testing tool, making it as a DevSecOps lifecycle also, which we will cover in the upcoming questions. Okay. Now coming to the topic of what is configuration management in detail, we will discuss. Let me try to explain you configuration management with the help of an example. So let's take a quick slide. Let us say you have 100 servers. Let's say you have 100 servers. On these servers, you want to install a package called as Tomcat. Then you have a package or a software called as Tomcat. Then you have 100 servers on which we have to create a database. Let's say employee. Now, if I asked you to connect to these 100 servers and install Tomcat, connect to these 100 servers one by one and create a database, would you want to create it? Would you want to do it manually, connecting to all the 100 servers? Of course not. We would not want to do it manually. It is time consuming. It is a repetitive task. I may make an error. Some servers I may miss. So what we do traditionally, we would write shell scripts. Shell scripts that will connect to the servers and will execute the script on it. We will copy the script on it. We will connect to the server. We will copy the script on it. We will see what is the operating system corresponding script will be copied. We will check whether Tomcat is present and then we will install Tomcat. We will create a database if the database is not. But that's again taking a lot of time. If on one server I'm taking 5 minutes, so on 100 servers, I will take 500 minutes to complete, which is a tedious job and I don't want to do it now. So here DevOps supports automation tools for configuration management. First, configuration. What is configuration? Connecting to various servers to make some change. Connecting to various servers to install a package, to copy a file, to deploy an application is called as configuration management. It's configuration. Now, doing it manually with help or doing it automatically via a tool is called as configuration management. So there is configuration management which can be done manually. There is configuration management which can be done automatically with help of tool. So that is what we are going to see with DevOps. So using a tool like Ansible, Puppet, or Chef, configuration management. Let's talk about Ansible. So Ansible is an automation tool where you can write the code. As part of this code, Ansible will easily connect to hundreds of servers in few seconds and install the desired package. So Ansible, Chef, SaltStack, these are examples of configuration management tools that connect to the available infrastructure and automatically parallelly connect to them or sequentially connect to them one after the other and do the desired changes, right? And also the main task of configuration management tool is to ensure the desired changes are always available. So there are two things, desired changes and current changes. Tools like Ansible will ensure the desired changes are always available. If the desired changes are not there, immediately they will run the code to make the systems as required by the environment for deploying the application. So that's about your configuration management, which maintains the important point is consistency. All the environments in the real time, all the environments in the real time requires consistency. Like test environment, you have your production environment, you have your pre-prod environment. It requires that your servers are up to date and have the same application, right? Have the same code running on. So that consistency can come with help of configuration management. So I hope we will stop here now. I hope you found this video on DevOps interview questions insightful. We are preparing more questions for you as part 2. So don't forget to subscribe our channel. Stay tuned and we will see you soon. Thank you so much. Let's look at the next two questions which are related with each other, which is what do you mean by configuration management and what is it that you mean by infrastructure as a code? So I would like to explain you with help of an example. Let me open a paint slide to explain. Assume a scenario where you have an environment. In real time, we have dev environment, test environment, production environment. Environments are nothing but set of servers where your application is running. So assume your environment has 100 servers. And our main goal is that these servers should have same setup. Consistency is the term that I'm looking forward to, that I'm looking at. So consistency or making your environment same across test, production, and dev. So let's say I have 100 servers where I want to install a package. Let's say there are 50 servers on which we want to copy a configuration file. So here is my question. Would you want to connect to the 100 servers manually and check if Tomcat is present? If it is not present, install Tomcat. Or connect to these 50 servers and copy the configuration file. Would you want to do it manually? Of course not. It's a tedious job, time consuming. So immediately you will say, Sonal, we shall write a script for it. Yes, if you're good at shell scripting, you can manage Linux platforms. You can write scripts for separately for CentOS, Red Hat, or for Ubuntu. Yes, you can write shell scripts. But in that case also, you need to copy the script, execute on each of the servers. So there is a manual task involved. So writing scripts and managing them is an obsolete job. With DevOps coming into play, we can automate this process of configuration management. So configuration is a term where you are connecting to multiple servers to make changes on the servers and to bring all the servers at the same level, that is consistency across the environment. Management, manually or automatic. Manage the configurations by manually connecting to the servers or using an automation tool. So with DevOps, we perform configuration management with help of tools. So if you make use of a tool like Ansible, Puppet, Chef, SaltStack, any such tool can be chosen. CI/CD on GitHub Lab also you have a process of implementing configuration management. GitHub Actions also provides you a feature of creating the infrastructure installing the required packages, and then integrating and deploying the applications. So various tools are available. I'll pick up a tool Ansible where you can write the code. Code is written in a very simple language, YAML. We write playbooks. In the playbooks, I determine or I declare the desired changes that I want to do on this servers. Ansible as a tool will parallelly or sequentially connect to all these servers. Within few seconds, the changes will be available. That's the power of automation. Now, when we talk about configuration management tool or any tool, there are two parts: desired changes that you want and the current changes. So Ansible, Puppet, or Chef or SaltStack, any tool you take, they always try to maintain the desired changes on the servers. But before we make changes to the servers have to be made available in the environment. We need to provision the servers. Hence, the term provisioner comes into picture. So another part, which is my second question, what is infrastructure as a? So using an automation tool to write the code and provision your infrastructure is called as infrastructure as a code. So before we look at configuration management, first look at what is infrastructure as a. Infrastructure is nothing but your servers, right? Your databases, your network, your subnets, your security groups, your autoscalers, your load balancer, Dynamo DBs, S3 buckets, storage. All of these constitutes to be your infrastructure, a set of servers where your application will. So we can manually create it or use an automation tool. So using a tool like Terraform, where we write the code to connect to the required cloud provider or your virtual, if infrastructure is in premise or any virtual server. So use Terraform supports virtual connecting to the virtual servers also. You can check the registry of Terraform. However, mostly you will see implementation of Terraform on the cloud. So the interview question is basically what is infrastructure as a key? So the plain and simple answer to that is writing the code to provision an infrastructure on the available cloud using the tool like Terraform or CloudFormation is called as infrastructure as a. Once the servers, that is your infrastructure, is available, using an automation tool like Ansible or Puppet or Chef to execute the code that will make changes on the server for the desired deployment and configuration is called as configuration management. So you have configuration management and you have infrastructure as a code, right? It's very, very popular tool nowadays, and there is a Terraform certification that you should target to do, isn't it? And as part of the courses also, you can learn Terraform and master it, which is really popular tool. Right? So that's the answer to your question. What is infrastructure as a code tool? So here you will see a simple code which is written. Infrastructure is a practice where you're provisioning. So there is a term called as provision. Provision, that means create, modify, or delete your servers on the cloud platform. So here there is a simple code written of Terraform where you are creating an EC2 instance of the desired operating system. AMI stand for Amazon Machine Image of the desired instance type, configuration of 1 GB and 1 CPU core. And this is the name of this. It's a small code snippet to demonstrate on how infrastructure as a code works to automate the process of infrastructure creation. So I will stop here. In the upcoming session, we will see a quick demo on how infrastructure as a code can be provisioned with the help of Terraform. We will be looking at more questions in the upcoming sessions. So I hope you enjoyed this session and you found it very insightful. We are preparing a lot of questions for you that will help you to clear interviews. So please don't forget to subscribe our channel and stay tuned for new questions upcoming. Thank you so much. I'll see you soon. Bye-bye.